In addition to being able to check for anatomical short legs and sacral unleveling problems, in the A to P lumbopelvic view, you can also analyze the lumbar spine to see how the biomechanics are doing with that and if there's any problems there. Okay, so we have a film here. Obviously, this person has a scoliosis going on. The right side of the patient is on the right side of the film, represented by the R in the circle in the upper right hand corner there. So how do you analyze this curvature and figure out how much curve is there? Well, the best way that I've learned to do that is to find the center of mass of each individual vertebrae and then do a best fit line down through the centers of mass of each of the vertebrae, and you'll arrive at an angle. So let me show you how to do that. First, you'll start by marking the outer edges of each of the vertebral bodies. So we're going to start down at L5, the lowest lumbar vertebrae here, and we'll mark the left and the right outer edges of L5. We'll continue up with L4, L3, L2, L1, T12, T11, and we'll try to squeeze in T10 up there. Good. So we have the outer edges of the vertebrae marked. The next part of the spine that we need to locate is the spinous process. Okay? So the spinous process needs to be marked at each level. That gets a little tricky on a scoliosis because the spinous process will rotate toward the side of convexity. So I'm going to start down at L5. We'll mark the spinous process. L4, there's a lot more rotation, so the spinous process is rotated over. L3, L2, L1, T12, and the rotation starts to come out up at T11, and then T10, it's almost in a neutral position again there, the spinous process. So now we have the spinous process is marked. Next, we are going to find the midpoint between the outer edges of each of the vertebral bodies. So those first 2 points that we marked on each vertebrae, we're going to find the midpoint between those 2 points on the outer edge. So I'll start down at L5. There's the midpoint there. L4, L3, L2, L1, T12, T11, and T10. Great. Okay, next we are going to find now for the most important part is actually finding the center of mass. So that's you're simply going to find the midpoint between the spinous process and the center of each vertebrae. Okay, so that'll be represented by these little small red dots. And we'll start down at L5, L4, L3, L2, L1, T12, T11, and T10. Next, we're going to do the best fit line. So we're going to draw a line for the lower part of the curvature and then the upper part of the curvature. A best fit line is a line that gets as close as you can approximate to hitting each of the red dots. So here's the lower best fit line that I've drawn and the upper best fit line that I've drawn. So not every red dot will be touched by these lines. That's okay. It's a best fit line. So once you have your best fit line, then you want to find the angle that these lines create. This is the angle that you want to measure with a protractor. So you would measure this angle, and we're just going to say that it's 28 degrees. So to summarize, this person has a 28-degree dextroscoliosis. They have a 15 millimeter sacral unleveling on the right side and a 6 millimeter anatomical short leg on the left. And that is how you analyze an A to P lumbopelvic film.